Montel on June 19th.
Yep. So for this meetup and this presentation, I have a couple of goals, since I think goals are better than an agenda for a meetup. First goal is to understand classic versus modern authentication. So the title of this presentation is Modern Authentication. So modern means that there used to be an old way, call it the classic way. You understand what OAuth 2 and OpenID Connect is. It's a pretty significant and complex protocol. So there's different types of tokens, and different types of flows in that. We're going to talk through that. And you're getting familiar with Azure AD B2C. So Azure AD B2C is a service that is in the cloud, and you can use it to embrace OpenID Connect and OAuth 2. So I'm going to show you kind of the features of that and some examples that we have utilizing that. Hopefully I can get time in there for a demo, and then also talk about how you could migrate users. So if you guys are using like a SQL table, for example, and you're still in that classic way, or you're tied to some not so nice identity store, we can talk about how you can migrate those users to B2C. Very creative and interesting ways we can migrate hashed passwords without actually having the user reset their password. That's a huge thing that, quite frankly, is the main thing that people come to us for that. So target audience, developers, architects, and SRE engineers. I think is that really where I base this deck off of, product owners, IT admins. There's a lot in here that is really technical, so if we get kind of lost with that, I'm sorry. So moving on, application authentication architecture, classic versus modern. What's changed? So I call this kind of the rebirth of identity, and like everything in technology, there was a problem, and then that spurred the reason to make a solution. So there's a lot of different problems, but I think these are a few that really stick to it and really kind of show why this is important now, this new modern authentication. So applications started doing too much, and what they were doing became more complex. So more compute power was needed, and development needed to split between teams. So instead of the monolith application, we started splitting things up into single-purpose applications. Users got sick of managing passwords, right? So we have all these different applications, and back in the day, we had to have a different ID per every application. That got really annoying. Businesses started to consume more vendor SaaS services. IT admins wanted to onboard their users rapidly. Many of you here might be using things like Workday or Office 365. Good example of still SaaS solutions, right? That we sign in with our identities. We don't go out and create an identity on their platform. Users wanted their services to communicate to each other without sharing their password. You all know this. I'm sure you've used Facebook, Twitter, LinkedIn, sign in with LinkedIn, right? I have maybe an app or website, share this post, right? It's going to do that on my behalf, but I don't want to type in my password to that site. OAuth handles that for us, and we'll talk a little bit more about that. Another option here, another reason here that is not shown is the increase in power that we have on desktop and mobile computing nowadays. So this is really more of an application architecture change, the single page application. So instead of a application that's doing most of the compute behind the scenes, we can now actually rely on the browser to do a lot of that processing for us. So when a browser is doing the processing and the browser is having to access the resources directly, we need a better authentication system to be able to orchestrate that and communicate back to the servers. So I found this online. It's a old screenshot from a products guide downloader pro that would want you to post a tweet to kind of share it out, right, to get more the marketing from you. But the only way you could do that back in 2007, Auth has been out for a long time, clearly, is to type in your username and password onto a website. So we were giving our username and password to Twitter and Facebook, and they were logging in and then using the APIs to post tweets. And that's pretty risky. And I'm pretty sure we saw, mass amounts of credentials getting lost because we can't trust, Joe Schmo is going to build the app that's going to encrypt this right and then maintain your password. And what if they're using a poor encryption algorithm? So, or hashing, I'm sorry. Pretty risky. So classic versus modern, right? Some key elements that kind of compare the two. Classic is typically one large monolith application, has its own local user store, so that's your SQL table or single IDP within the application. It's not a global distributed identity store. User has different user IDs between systems, so no SSO. or modern is a little bit different, where we have not one the monolith, as I said, but many different applications. App has no user store, uses an OpenID Connect IDP like Azure AD, Okta, Ping1, there's a ton of them, one login. User brings their own identity. So instead of having a sign up within the site, we can consume the identity. Now, sometimes sign up is still valid. We still want to have the user create their own account. Maybe they don't want to use their identity. That's an option. But we want to offer the ability to bring their identity. So if I'm building a B2B application, I want you to give me your Azure AD login. I want you to take your Google Apps login. And signed in once. So once I've signed in, I can now access all of my applications. So I can not only access all the applications within 10th magnitude, but I can access any other application that consumes my Google Azure AD authentication without having to sign back in. So diagram that quickly shows it. User wants to access application 1. They type in their username and password to application 1, and then application 1 does its business with the web API. User wants to now access application 2. They have to type in the credentials to application 2, and then that application will communicate with the web API. Kind of two isolated efforts. You know, moving to modern identity, just taking a look at how the plane has changed a little bit. We still have our application, we still have the web API, but we introduced Microsoft Azure Active Directory, and take Azure Active Directory and put that, put Okta, put Ping1, or put homegrown IDP there. Don't recommend you do that because it's a lot of work, but that can be plug and play with any provider. And the user accesses the application, and then they are sent back to Azure Active Directory. Now, instead of providing the username and password to the web app, we're actually signing in through Azure Active Directory. So not only do we get all the benefits that I talked about with modern authentication, but we're out of the identity business. We don't actually touch those passwords ever. So if it's our users who are still local accounts, or if they're bringing their own identity, we have a separate entity that's managing all the security and credential store for our users. And so once I've signed in, that token from the application now is sent to the token is sent from Active Directory to the application, and then the application can then use that token to access the web API. Now, this can either be on the behalf of the user. So if the user was doing an operation against Twitter, the app was doing an application against Twitter or Facebook, we'd actually be using that token to do the actions on behalf of the user. But as an approach to just building an application, we'd be using that token to just access applications that are secured on our end. So 10th magnitude, for example, might have an application that has our suite of APIs behind the scenes. We put API security on top of it, and right before then, we're inspecting that token to make sure, hey, did it come from our Azure Active Directory? If so, we can let that user in. Things get a little bit interesting when we want to tweak things and add in social IDP or bring your own identity. So with this, instead of the user signing in to Azure Active Directory, our apps still go through Azure Active Directory, but we redirect the user to one of the social IDPs. So that can be Facebook, Google, Azure AD, Amazon, LinkedIn, a couple times. User signs in there this time, or if they're already signed in, they'll just be passed back through. And then that token goes back to the application, and then they can access the application and web API just like before. Now they can also go back to application 1. It's not shown, but once we have that token, it's minted for any of our applications that are affiliated with Azure Active Directory. So that gave a good overview on what's today. Here's what's possible. Now I'm going to talk more about the protocol. So OAuth and OpenID Connect, two connected but separate things, and I'll show you how it puts together. So OAuth 2, this is right from Wikipedia, and I think it's the best definition for it. An open standard for access delegation commonly used for internet users to grant websites or applications access to their information on other websites, but without giving them passwords. It was built a long time ago, OAuth 1 and now OAuth 2. It was collaboratively built by Google, Facebook, Twitter, Microsoft, many individuals and many different organizations. It was really a huge effort, and it solved a lot of problems, right? This was the birth of, of microservices that needed this, and SaaS applications to be able to consume these different identities. So big motivation there for organizations to hop on. really simple sequence flow on how it works, and let's keep clear the lifelines here. It's the user's browser. So when we talk about OAuth, what gets confusing to people is, okay, how is this data being transferred between Twitter, between Facebook, and my app? What's key to remember is that it's your browser that's doing it. We're using HTTP, we're using 302 redirects to take your token that you've got from your IDP and send it back to our app. So that's the key mechanism in how the data is being transferred back and forth. So your user's browser, your app, and then Twitter. So sequence starts with your app presenting a homepage, so your user getting that app. You presenting a login with Twitter, which is actually a link to Twitter, and that then user then gets the Twitter sign-in page. And what's different about 2 and 3 versus the picture I showed earlier is we're signing in with Twitter, right? So at this point, the user's domain is twitter.com in their browser. They're typing in their credentials there, not on our app. And then once they sign in, 2.1 shows we're redirecting back to the app with the access token. So when you make that initial request to Twitter, things you've probably seen before, reply URL, that's where we've configured our app to authorize to send that token back to a different endpoint for that to be consumed. Now, once we have the token, still back in the user's browser control, the user will then present that token to the application, and the application now can then use that token to post on the user's behalf. So that's about authorization, right? So we go back here, the key notion was grant access without using the password, right, to use their APIs, but that doesn't really talk about identity. So that brought in OpenID Connect. Now, before OpenID Connect, people were doing like blanket scope requests to null APIs to just get information about the user. It was kind of ghetto. So everybody got back together and said, okay, let's build a standard around identity, right? Let's just, how do we know who the user is, right? Before we're talking about accessing APIs, but how do we know who the user is, right? Their title, their first name, last name, all those things. So OpenID Connect is OAuth, JSON, some new rules in RFC spec equals OpenID Connect. So OpenID is an amendment to the OAuth spec, so it sits on top of it. It's not a new protocol, it is OAuth behind the scenes, right? It's just more rules on how do we define a JSON web token. Right? In the next slide, so authentication layer, controlled by the OpenID Foundation and relies heavily on the JSON web token. So tying these two together, which one do I use? You start with OpenID Connect. Not all applications need to share APIs with other services, right? If you're a business and you're building an application, you might not have a need to expose those APIs to other developers, right? You just might want to sign in and consume identity. So don't worry about OAuth. Start with OpenID Connect until your requirements change to share that API externally with others. Then we can talk about OAuth. And that's my last point there. Not every app needs OAuth APIs to share data with other services, but your app will need a way to sign in the user authoritatively. So digging deeper, talked about OAuth and OpenID Connect and what they are, but there's a lot more behind the scenes, and that's the type of tokens, the JSON web token, and the different OAuth flows. Now,
is that a framework on top of JWT?
JWT is what? A framework?
JWT Token that you're using, the OpenID. Is that technically a framework that is using JWT Token?
Yes. So OpenID, in the OpenID Connect specification, we talk about how to utilize the JSON web token and the specifications around that to authenticate the user. So it's OpenID Connect plus the JSON. So in my diagram, I showed OAuth plus JSON, which the new rules are the JSON web token. So back to this guy. OAuth, JSON, right? That's just JSON document. Some new rules in RFC spec, that is pretty much your JSON web token, right? The rules around defining that.
Got it.
An easy way to think about it is OpenID is a protocol explaining how to obtain the token.
Oh yeah, the reason I asked that question is you could technically just go use JWT if you can actually build authorization for what you need at each step. But if you can use this OpenID, then you technically have a framework that you can utilize without having to do all the heavy lifting on the back end.
Yeah, and plus one of the best rules of security is don't invent your own.
Yeah, and the key here, back to the issues that we had before, we don't want to roll our own because we want to consume other people's identities, right? So we all want to get everybody on board with these standards, Azure AD and, sorry, not Azure AD, but OpenID Connect, which hopefully our IDPs are based on that so we can consume these identities. So going back, what is JWT, type of tokens, and OAuth flows? So there's 3 types of tokens: ID token, access token, and refresh token. ID tokens are used to identify the user and display information to the UI. So ID tokens are the core of OpenID Connect. Access tokens are used to access resource servers such as web APIs. So if I go back to that diagram that I showed between that token and querying that web API, that was the access token, right? So an ID token is not an access token. An access token is actually gives you permission to do something. An ID token is just simply who I am. And a refresh token is used to renew ID access tokens without user interaction. So I think a really, really simple way to tie this in your head is if you look at your phone, right? I'm sure all of you use some sort of online banking. You have your online banking app on your phone. What happens when you initially sign in is you sign in, so let's say Capital One, right? I have Capital One. I sign in, Capital One receives back an ID token, right? It tells me who I am, but then they also receive an access token. That access token lets me do things like check my balance, transfer funds, and manage my accounts. But that access token, it'd be really a bad choice for me to keep that token on my phone for a long time, right? Capital One is obviously a secure organization, so these access tokens, they expire very shortly. Sometimes it's 30 minutes, sometimes it's an hour, right? And what we do is we take that refresh token and we use that to generate more access tokens. So the refresh token is kind of pointless other than to get more access tokens, but when we're looking with distributed computing, right, it's very hard to build a server that, a platform that has thousands of different APIs, right? And when I kill that user account, we're tying it on the expiration of the JSON Web Token, which I'm going to talk about further more. So we build a system and say, okay, when I terminate a user, let's say Montel Edwards, right? He's a bad customer now. We're going to make our jobs 1 hour. We're going to accept 1 hour of time where from termination of account that Montel could access a service. And once that time period is hit, that access token is denied. Now when I try and go make new tokens with my refresh token, then the service says, no, you're not allowed, and there's no longer mints me an access token. Now,
how does that work behind an SSL?
Sorry?
How does that work with or without an SSL certificate?
So it's not really, with all these, right, when we talk about back, where am I? Here, right, the exchange between the user and Azure Active Directory, we're using, as I said, the browser to do this. So we make an effort to verify the token, right? So nobody's spoofed the token, but we rely on SSL to make sure that we're communicating with the right endpoint. So it's still typical web traffic, right? So it's the same question on how do I know that I'm accessing the right website? How do I know I'm communicating with the right website? So OAuth itself relies heavily on HTTPS, right? So we always, when we're talking about this exchange of data, we always make sure, and the IDPs by default always require that use HTTPS endpoint. So we'll apply URLs require HTTPS instead of HTTP, so nobody can inject that, man in the middle, take that token as we have the exchange. Did that answer your question?
Yep.
Okay, so JSON Web Token. This is a raw view of what a JSON token looks like, and there's a couple of different elements. So as you can see, it is a JSON document. There's 6 elements to it. And in order and highlighted is first the signature, right? So that's your key ID value there. I'm not going to go in depth on what the key ID value is, but it essentially points back to a RSA value that you can verify the key with. Time period of expiration, so that's expiration date, which is a Unix timestamp, and then NBF, which is not before. So we say this token is only valid until this, but it wasn't valid. It's valid up until this point, but should not be valid unless this time came. So it lets us prevent replay attacks of the token. The issuer, so this is who is issuing the token. In this case, it's my IDP. So when I receive a token from Facebook, this will say facebook.com. When I receive a token from Azure AD, it will say Azure AD within that. The subject claim, so that is a unique identifier of the user. So this is part of the protocol. When I talk about back those rules of OpenID Connect and the JSON Web Token, this is key, that every token has a subject claim. So when you're building your apps now, you might be using something like the email address as your identifier of the user. And that's pretty risky because I can get married and I can change my email, or I can just change my name. So a standard practice is we establish a immutable ID of our users. So I technically could make my email a subject claim, but we always want to make that an immutable ID. So right, even when I communicate with Facebook and I receive a token back from Facebook, Facebook is not going to have the subject as Montel Edwards. It's going to have a Facebook user ID, right? So that's a typically a GUID value that identifies me and will always identify me no matter what changes about me.
Quick question as far as the subject goes. Who owns the subject? Is it Azure AD, the one giving you the token, or is it Facebook? And the reason I ask is if you're not doing consumer, if you're doing like enterprise based federation, a lot of the subjects I see are, if you're using like Active Directory, on-prem Active Directory, the subject is the user's email address, and that's just because that's the way the corporation set that up.
Yep.
So if I'm using Azure AD to federate with an on-prem ADFS, would Azure AD generate that subject, or is that generated by that on-prem ADFS?
Yep. So looking at this diagram, what's key here is using Azure Active Directory B2C to do the federation with the IDPs, right? So each one of these is going to, when they send a token to Azure Active Directory, they're going to have their own token configuration. So Facebook's going to say perhaps email, and Google's going to say something like email address, and they're going to have perhaps their subject claim is ID, and another one is GUID, different sort of values within their token. Now, when Azure Active Directory consumes those, Azure AD B2C, so B2C and Azure AD are two completely different things. We're not going to talk about that today, but B2C is the main service here. When B2C consumes these tokens, it has a one-to-one relationship with each IDP to verify that token, right? So the first thing in this flow that we didn't talk about was B2C verifies that token, right? Then once that token's verified, B2C then what we call remints that token. So it takes the claims and then issues our own subject claim on top of that. So in this instance, although I've signed in with Facebook and although I don't have a username and password stored in the directory for my user, I still create what we call a stub user in the directory. So Azure Active Directory will essentially have this user object stored in the directory that will have mapped to it the subject claim of Facebook, but then our subject claim. So what that allows for us to do is have the portability of identities across different IDPs. So today I sign in with Facebook, but tomorrow I might want to change that to Google, or I want to now then have username and password. So we can have different IDP sources here, but our directory tells which one to go to and then has our own subject claim for our users. So we always will have that GUID format because that's what Azure AD expects. I'm sorry, that's what Azure AD generates. Does that make sense?
Yeah, and so just to play devil's advocate here, if the Google Plus, let's just say that was using my email address as a subject, I'm not saying it does, let's just say it did.
Yes.
And I changed my email address,
yeah,
and that link with Azure Active Directory is broken. So when I log in, it's not going to know who I am.
It's not going to be broken. It's going to know you're a new user. Okay. So that is the risk. That is not on you. That is the onus of the IT, right? So you build enterprise applications. Your IT, unfortunately, of your partners or consumers is using a non-immutable ID as their subject. That's on them to handle the exchange, right? So when they know that if a user changes their email, the source systems are downstream are going to determine them as a new user. So on top of application identity, we also consult organizations on the enterprise Azure AD, and that's a big no-no. We tell every organization, do not call your subject claim a non-immutable ID because you're not going to have services like like Workday and other SaaS providers know that this is a non-immutable ID, right? Subject means, in most cases, always the immutable ID of the user. That's not supposed to change. True. Okay, going back. So we talked about.
I've got a question.
Yeah.
It's really the same thing. So you said that federated or what you call stub users can have the GUID in there to identify him uniquely.
Mhm.
Say at Facebook, he logs in first time, creates a stub,
Yep.
plugs in the GUID that represents the ID.
Mhm.
Next time he logs in as Google, right? Completely different credential.
Yeah.
How does he end up associating it with the GUID from Facebook?
Yeah, so that is an integration that is handled with the application. So we always need to have some sort of anchor to relate the user back. So at that point, once I'm already signed into the application, my application could expose a new sign in, right? So we already have
And so it's
context.
an application logic.
Yeah, so we have context. So it's application logic that is also tied into B2C logic. So once the user signed in, essentially we would expose a linking user flow. So it would accept a claim from an already signed in user to go to Google or Enterprise Active Directory or whatever it is. And we would, instead of looking to look up that user based off of their immutable ID from their old provider, we will then look to just match it with email address or whatever the context of the user if they were already signed in. So does that answer your question?
Yeah.
Yeah.
Thank you.
Okay. So issuer. Yeah. So issuer talks about who issued the token, subject claim, immutable ID. Audience is who the token's intended for. So if I'm requesting an access token, and I'm a large organization and I have many different APIs, I might only want an application to have the ability to access, to request tokens on APIs that it's relevant to. So this is a value that API management service would inspect and make sure, hey, does it match the audience value that I'm allowed to consume tokens with? And then claims about the user. So that's the OpenID Connect part really shows right here is the information about the user, name, IDP, job title, postal code, and anything else we want to include. So ID tokens, this is the flow of how they're obtained. Web app calls out to its IDP like B2C. And what you're seeing there in the text is the parameters that are on the HTTP request. So an authorized call with a scope of equal OpenID Connect, and then a token is then returned. And then access tokens are a little bit different where a call is made, but instead of having just OpenID connected to the scope, we actually type in the identifier of our web API. So this is really relevant to B2C, but almost every other IDP is the same. And then in that case, we then receive an access token, and then we're able to use that access token to communicate with web API servers. So in this case, I'm going to go back one real quick. You saw we requested our scope web API A. We got a token back for web API A, but we can't access web API B. Now, this can be a little bit confusing because we just talked about sharing tokens across different services. Well, I can still have single sign-on, but issue tokens relevant to this particular app. So say I have a suite of applications. Okay, I have maybe a portfolio of 10 different applications, right? I'm signed into my IDP, but I only want my let's say fleet management app to access APIs that are related to fleet management. So I sign into fleet management, I get a token back that is, instead of saying web API there, let's say it says fleet management. So this token has access to all fleet management web APIs. So when we have a token for a web API, that implies a collection of APIs or one API. It's up to you. But we're limiting our scope to only what's relevant for the application. So when I have the flexibility of perhaps not letting in certain users, right? So my user who is at access to fleet management might not have access to cost management, different applications. So that is how we can kind of block off access with that access token in the scope. So going forward with refresh tokens using the code auth flow, right? So we make that same request, we make it with the scope, OpenID, but then we also add another parameter of offline access. And when we get that, we get an auth code first, and then we exchange that auth code for a refresh token. So the refresh token I was talking about, right, with the Capital One example, that's my kind of ticket to get more long-lived tokens. And even more onto that, you really know when you have a refresh token when you are using things like Face ID or or the Touch ID. We actually encrypt that refresh token with your biometric. So when you are actually signing with your face, we're decrypting that refresh token to get another access token, and that's how we can reuse the app going forward. But that's also why we first type in our username and password, then we can enable Face ID. So, couple different flows. I'm not going to go through the middle one. I don't have time. I can only pick two. So implicit flow and public client flow, those are the most popular ones. Implicit flow, browser requires ID access tokens directly. This is your single page web application. If you don't know what a single page web application is essentially what I talked about earlier where the browser is doing a lot of the legwork and coining these web APIs for you. It's not doing that just on a simple web page that's really all JavaScript-based web apps. Public client flow, that is your phone app. That's your desktop app. So it's calling out to a different API. The API is still doing a lot of the calling for you. So implicit flow. Step one, the browser attempts to access a protected resource. So that's my initial kind of presenting of the web page. I'm then redirected back to BDC to authentication, BDC active ping 1. Make a request in with the different parameters, my scope, client ID, and redirect URL. So redirect URL is what I talked about earlier, right? That's the protection mechanism so that we know to only send tokens to the right source. Then moving forward, starting on the right with number 4, we redirect back to the web API login with that token. So I've already signed in. And then I'm able to redirect back to the application with my token. So I've signed in through BDC. BDC sent me a token. Now I'm going back to the application with my token. And then the web app is able to then verify that token with its metadata. So part of the OpenID Connect specification, which we aren't going to have time to talk about, is the metadata endpoint. So that's a configuration that we supply within the application that tells it where's the location of my JSON web keys. So that JSON web keys are a list of keys. So that's going back to this guy, right? It's this KID value. I might have 10 different keys, right? When I get this token back, my application is going to look at that metadata, look at this key value, get the key, and then make sure that this signature, which you see at the bottom, which is fairly long, matches that. And that's about it. So eventually your access token will expire. What happens then? We'll make another request out. But what's different here, and this is variable with different IDPs, but this is how it is in B2C. We provide that same request behind the scenes. So this is typically an asynchronous call that will happen in an iframe. The user actually doesn't know. So I can maybe have my single page web application and I want the user to sign in indefinitely, right? But I still want to see, are they a valid user? And to do that, we make the request with prompt equals none. And what happens is in that iframe, behind the scenes, Vita will reply back with a new token or an error saying a UI is required. So when that access token expires, we're going to make that call back out, and the BDC is going to say, okay, Montel was either terminated, changed his password, or that token was invalidated, and redirect him, please, to sign back in or present a different error. Any questions on the implicit flow?
Not a question, but it's probably worth noting though that the implicit grant type has been deprecated by IETF as being insecure.
There was some mechanism around that, which I can't. I remember reading at that, and there was one control. Do you know what it is on top of it? That I know the whole. I know it's like the baseline, like as is insecure, but there's a mechanism on top of that.
I think what you're probably thinking about is Pixie.
Maybe, I'm not sure.
Pixie is designed to plug a security vulnerability in the authorization code flow.
Got it.
But this one has been deprecated, right? So if you look in IETF now, there's a new BCP. They created one for native apps, and now they're creating one for the single page apps. And they're basically, they're essentially saying, well, we made a mistake. Don't do this.
Yeah.
What you read in
RFC
RFC 6749, and use they're recommending instead the authorization.
Got it. Do you know why it's so insecure?
Yeah, it has to do with the fragment and the way that the token comes back.
I'm sorry, that was it. It's posting back via fragment. That, but not the actual implicit code flow itself, right? Coming back with the forms post is still
they're deprecating implicit.
the whole thing.
Saying don't do it.
Got it. I understand. I thought it
Token's
was
stored on the
fragment.
client, so
Sorry?
the token's stored on the client, so it's implicitly insecure. Whereas the authorization code, you store the token on the server, so it can never be stolen. So even if you, when you're storing it on the client, it's vulnerable to a variety of cross-site scripting attacks. If you're storing it in a cookie, you can still take advantage of that. So a dev needs to make additional preparations in their code to make sure that doesn't happen. So,
Yeah.
Well, even with authorization code flow, at the end of the day, if it's a single page app, it's going to be in the browser. It doesn't make a difference what protocol flow you use to get the token into the browser. It's still going to be stored in the browser.
well, authorization code flow, you can store it in the server because the handshake happens on back
Not
channel.
for a single page app.
You can still do it single page app.
Well,
You still need to
depends how
store
you've
some
implemented it.
information about the user, right? So even if I have the token stored on the server, I might have a cookie that identifies that user, right? And I can move that cookie somewhere else, or I can have some sort of token. So whether or not it's the actual raw access token or it's some mapping to it. I remember like we had a talk with Microsoft about this, and it was really on the fragment issue, right? And I know ITF is deprecating it, but when we talk through it with them and the identity engineers, it's the controls around fragment. Yes, we can argue that those are technically insecure, right? But when we're doing other mechanisms like proper API management on top of it and validating that token, right, and where it comes from and who's issuing the request, a lot of those security concerns can be mitigated, and the benefits we get with it are still more acceptable, right, than the potential concern that we have mitigated with other controls. That makes sense?
Sure.
Yeah. So the big thing in this, right, is how you protect this web API, right, on this guy over here, right? And within Azure, we have a very impressive service called API management that can really do intense inspection of that token. And then we can have other mechanisms to ensure where that token came from and make sure that's valid and not been expired and not been used by someone else than once it took. So code flow, public. Native app, I think, is a better example to use for this, but it could be a desktop app. It could be a typical browser application. Requesting the auth code. In this instance, the users use the web page pop-up to sign in, directed with the code to our redirect URI. Reading that code for an access token, and then send future requests into our web API with that access token and authorization header. Same thing with implicit. Eventually, the access token expires, and the flow is pretty much the same. We call back out to that web API, and we get a notice that that token's expired. Now, maybe my app's a little bit smarter, my mobile app, and I'd actually notice the token's expired. I'm not going to make that call. Design decision there. But either way, we determine that the access token has expired. We then request a new token and with our client ID and a refresh token, and then make the call back out to the web API. So, talked about OAuth, OpenID Connect, the different flows. Now moving on to Azure AD B2C. So B2C, in my opinion, I've worked with Ping, Okta, touched a little bit on Auth, Zero. B2C is best out of all of them. It is a little bit more complex, a little bit more pricey, but it gives you an amazing amount of flexibility. And I'm going to hopefully have time to talk about some of our use cases that we've developed with it. But it really lets you develop the ideal identity experience for your users, right? So coming in from different identity sources or migrating from wonky identity sources without impact to your user, it's all there. So B2C, I think some kind of more business value to it. It allows you to develop applications that are more secure, resilient, and easily accessible to end users in less time. So that notion of building an IDP to consume these different services, when I talk, when we go back to that modern authentication side, to roll our own identities source, right, that stores these users securely and maps those GUIDs and issues new tokens, that can be a significant effort to undertake on your own, can be done. but it's going to take you longer to develop your app, right? So on top of that, what you get is you get many of your applications. You can have many applications, but you're always going to have one endpoint, one claim schema, and one protocol. So when we go into organizations who are moving from their weird IDP, it's mostly because I got a new app team with some kids who just graduated college, right? They know how to develop great single-page applications very quickly and very nicely, and they ask, where's your OpenID metadata, right? That's all I need, right? That's all I need to let your users in. When you adopt B2C, you adopt really any other IDP for your authentication source, it lets you develop applications and have everything you need to consume identities for all your different users, right? So if I'm a B2B organization and I have a federation with different partners, maybe I'm McDonald's and I have a Pepsi federation, right? I can let my small app team consume this endpoint and have everything they need to federate with Pepsi and consume those Pepsi identities. And they, on top of that, right, they're going to know what claims to expect. So if it's Pepsi, but then I'm going out to Coke, right, these claims are going to transfer back and forth, and BDC is going to make sure that, as you talked about, if it's email address or email or ID, it doesn't matter. BDC is going to do all that transformation to a claim schema that we're all familiar with. So obviously bringing your identity, cloud-powered protection, and managed access at scale. Those two, I think, are really emphasized with B2C because there's no more trusted identity store than Azure AD. Most of the Fortune 100 uses Azure AD. Everybody's using Office 365. Microsoft puts a lot of investment towards that. It's incredibly secure, but it does it in incredibly less user intrusive ways. So a lot of AI, a lot of creativity around, okay, how can we tell it's a botnet without actually having the user pick, okay, what did I get today? I was like, pick out the squares that are a fire hydrant, Those things are kind of the easy way to make sure it's not a bot. But Azure AD has a lot of creative ways it does that, and you can look online and read more about that. So this is the visual, right, that we showed on our meetup, and I think it really shows how BDC can tie everything together. So if I have multiple apps and on-premise and all my different devices, and I have my employees who want to access apps, and I have my partners and customers, it can be a huge mess and give your developers a lot of anxiety. But if you can extract all the way, put into B2C, you get a nice little pretty endpoint in that claim schema and can onboard all of your applications without really having to worry about much. So Azure AD B2C, you have your customers, your social identities, and perhaps your business and government identities. So whether that's Contoso Azure AD, 10th magnitude Azure AD, or perhaps federal government uses ping or something like that. You can bring all those on, right? Then you have your applications. Obviously, you want your users to access. B2C sits in the middle, and that is how you securely authenticate your users to all your different applications. It's a rock solid and secure service, has more certifications than any other cloud provider. It's GDPR compliant and really probably the best identity store that you can use, coming from somebody who's used many of them. So back to the customization, this highly customized identity engine. So in B2C, we have a definition and an element we call the user journey. So the user journey, think of it kind of a little bit self-explanatory with the word, is it's the journey the user takes from initial sign-in request to token issuance. Token issuance is typically our last step. So between there, kind of left to right, as you can see at the bottom, we can do whatever we want, really, between those steps in these user journeys. So perhaps I want to present a button to the user and say, okay, select Facebook, Twitter, Google, whatever. But let's say maybe I am a B2B SaaS provider, and let's say I have 1,000 different IDPs that I federate with, right? 10th magnitude, Ernst & Young, Pepsi, Lexmark, all these other ones. Maybe I just want to ask the user, what's your email? And then I'll send you to the right location, right, based on your IDP. We can do that by querying out a REST API, so taking in that email address of the user, right, on our B2C sign-in page, querying into a REST API and saying, who is this user a part of, right? Are they a Lexmark user? Are they a McDonald's user? And then send them to the right API. I'm going to demo that. And then I can do whatever I want with that after that, right? We have hooked into Experian Credit Union for verification of the user. So maybe we're asking you your credit bureau options, that when's the last time you lived here, or who you opened this bank account with. maybe we want to ask the user what's your favorite color. We can do pretty much anything that we want with the identity experience framework. And with that, it's not only doing things, but conditionally doing things. So maybe something came back with a wonky value, we want to verify more or send them to a different location. Lots of options there. So in this view, what we're showing is that BDB app I said, where I have an application, one app, but I'm consuming identities of my customers, my employees, and my partners. So my employees might log in to administer the app. My partners might be think distributors, right? But then actual end users, the distributors sold my product and now my consumers come in, we can access all of those identities through different elements on the site, and we can do it either by presenting buttons like this or sending an email address. So all of those are features of B2C. What you're seeing right there would be the B2C sign-in page that your app would redirect them to. So demo, I'm going to show you a couple of things.
I have a question on the last slide.
Yeah.
So if it's using OpenID Connect as a universal solvent and everyone's exposing an OpenID provider, what difference does it make if it's an individual customer versus a business customer versus a business partner?
It doesn't. So those are atomic business verbs towards us. What we're showing is consuming different types of identities. So still, unfortunately, B2B can be SAML or WS fed. On the consumer side, we're maybe having that local account authentication, which on our end is more of a proprietary thing between our IDP, or maybe then we're using Facebook. So the emphasis here is on, especially as I didn't mention the SAML2 and WS fed aspect, is that we can federate with different IDPs of perhaps of different protocols and consolidate everything in to our claim schema. So even if everybody was OpenID Connect, they're still going to have different claims than we expect, and we can map those to what we expect. Does that make sense?
Yeah, and that's fair. Actually, most enterprises are SAML still today.
Yeah, absolutely. So, demo, 1 second. B2C right now, and we have different options here. So this is not the out-of-the-box view where it's customized so that we're only showing the sign-in name view. But in a consumer app, you might have the Facebook sign-in button, the Twitter sign-in button, various different buttons. So what's happening here behind the scenes is I have my user journey. Step 1, we're going to do what's called self-asserted. But, and in this instance, it's email. Now step 2, so the B2C service is out here, so let's just put it in a triangle. For some reason, we like to put triangles for directories. So we're going to take my email, right? That's going to go into B2C. Then we have another entity down here, which is essentially a weird shape, but it's a REST API. Another entity down here, which is a square for you, a little table, just happens to be a SQL table, where we have our users mapped to particular IDPs. Now, there's a way we could kind of have this data stored in B2C, but this is typically a highly volatile configuration within the application, and I'm going to show you this why in 1 second. So my table, for example, right, I can have, let's say domain, right, so domain 10n, like 10th magnitude, I know you can probably see this. And I might have a user here as well, so maybe Montel, right? And when I sign in, I'm going to capture my email. It's going to go to B2C. B2C is going to hit this REST API, send in my email here, and this REST API is going to query and find that user there. So what I was getting at is, why don't we just have this data mapped in here? Well, this is more volatile most of the time, right? This is where the application, maybe the enterprise has an onboarding process where, okay, we've accepted 10th magnitude as a customer. We've onboarded 10th magnitude as a customer. We want to access it within our own database. So we could, map it either way. But essentially, we're going to come back, right, and say, okay, 10th magnitude equals AAD. And then we're going to send the user to AAD. And they're going to go back, right, with that token right there. And then they go now, which we forgot to include, to app. So write it out, self-serve email, query API, send to IDP, and then login. So this flow is really good. Like when I said I have thousands of different IDPs. So I think it was you said, right, you do B2B communication or application, right?
Yep.
You don't want to expose 1,000 different buttons to all your clients, right? This is what Microsoft actually started when what they call homegrown discovery. So when all of you access Office 365, if you have it, you type in your email address, you click next, you're technically behind the scenes then redirected to your tenant, right? So then you'll see your company's logo. That's what we're doing here with B2C, the same thing. But what's different is we're doing it with many different IDPs who are perhaps different protocols.
Is that custom Azure B2C or something you guys wrote?
That's Azure AD B2C.
Built in Azure B2C.
Yeah. So that's the only thing that is what you or we would write is this guy right here. This integration to query this is standard. So this is a what we call a REST API provider within B2C that you pretty much just type in your URL, right? And what am I going to send it and what am I going to expect? And then you within B2C define what is that action. In this case, we're telling you to go to this IDP, right? Azure AD. So in this demo, I think I have Azure, Google, and Ping 1. Ping 1 I wanted because Ping 1 does support OpenID Connect, but also SAML. So I'm going to sign in with a few different emails. First, it's going to be my 10th magnitude one. I'm edwards@10thmagnitude.com. Click continue. Now, this is Azure AD B2C actually querying that REST API. It's a little bit slow because we're using a logic app. They're not too fast. I think it's been sitting there for a while. But what B2C is also smart enough to do, because the IDP supports it, is it provided something called a login hint. So with identity and doing application development, the most important thing is the user experience. By default, I would have been redirected to my API, my IDP, and I would have had to type in my user email again. That's pretty annoying. So Azure AD and almost every other IDP supports the login hint, which I should see in the URL somewhere. Yeah, right there. So when B2C made this request, URL encoded my email address, medwards@10thmagnitude.com, so the user didn't need to type it in again. So I'm now going to type in my password, and this is the experience right from a fresh computer. If I was already signed in, I would just dial in through. Sign in. Do I want to stay signed in? Sure. Now I've already done this demo, so I didn't get the initial, hey, this app is requesting access to your info, but that's what you would have got from that. So that's my token. So this is JWT.ms. It's a JSON Web Token decoding service. So in this instance, what we were just talking about, which isn't that secure, is the fragment. So it sends in that URL as a fragment, as you can see up there on the top, and JWT.ms reads in that fragment and decodes it. So this is my JSON Web Token, right? All the values that we talked about before, subject, audience, and the expiration, my claims, and then some other custom things we have in here as well. So just to kind of show off about B2C, there's another step in here, which is actually going on, where let's get rid of login. Let's say claims enrichment. And all of these are, you have lots of different options, but it's always on what are your requirements for your app and the best way to get your data. A lot of our clients, and I'm sure also a lot of you as well, have the users that come in, but then they have this database here, right? And it's perhaps a mapping of subject to PII, right? We don't want to store PII. It's we're weird about that for some reason. So once I send the IDP to get the token, once I have that token, that's where we're at, back on out here. B2C can then call out another REST API. Instead of looking for, who is IDP, we can say, I have a subject of this user, send me more claims in. So in this example, things like cost center, department, what is the one? Badge ID. Those are values that are enriched as part of my claim set. So if there were a specific value that maybe you want to have self-asserted by the IT organization, right? So you have that B2B application, IT admins always want to include a specific value. You might have that stored in there, right? And always query and find that data for you. So
I have a quick question.
yeah.
You were saying that everything after the B2C, you guys are pretty much working with your clients up to the REST API.
Well, we also do the REST API too.
You do the REST API.
Yeah, it's up to them if they want us to do or not.
Have you heard of serverless framework or serverless.com? It's an open source framework for basically building your own REST API. Could you easily just kind of place that in? Because I have an enterprise version that you could, I'm wondering, could I theoretically plug that in to B2C and use those endpoints to connect into something like that?
Yeah, absolutely. I mean, in Azure, we have exactly the same thing. I mean, there's lots of spin-offs of them now. They're called Azure Functions. AWS, it's AWS, Lambda Functions. It's essentially taking in just that snippet of code, putting it somewhere that expects a HTTP input and output. So 100%. Like, as I said here, this integration is just a URL. And we say, I'm going to send an email and I'm going to expect, department or IDP value. So IDP equals Azure AD. So behind the scenes, we're making a precondition that says if I receive back the IDP value of if I receive back the IDP value of Azure AD, send them to Azure AD. So yeah, you can put this guy wherever you want. It just needs to be an HTTP endpoint.
Thank you.
Now we secure that via either basic auth or certificate authentication. In B2C, there is plans to actually do OpenID Connect between the REST API, but that's not available currently. So as long as it supports basic auth, you're fine with that. I'm going to sign in with my ping account. So I have at monteledwards.com demo ping1 directory, so I'm going to click continue. Now I did that REST API call again, but this time that value came back of Montel ping1, and in my B2C policies I've said, hey, now go to ping. So now this is SAML, right? And I have a little nice extension here that lets me see that SAML request. So we could see B2C send an auth request to destination sso.pingidentity.com. So we're clearly looking in SAML. I'm going to click sign on now. And behind the scenes, Ping sent in a response to B2C, but I clearly didn't get a SAML response right to JWT MMS. There's no JSON Web Token in SAML. So right now I'm working with a JSON Web Token. So I did that translation between a different protocol to our app. So back towards that business value, right? I don't want to build my apps for SAML, and I don't want to support different protocols, but I want to support whoever you are in any of those protocols, right? So I let my developers build on OpenID Connect, and we'll consume your SAML identities. Let me do that translation for us. And one more, and we're going to get an error back on this one. I'm going to show you why. So notice that I typed in m.diante@gmail.com. And I'm going to sign in with m@monteledwards.com. So this is kind of a flaw, maybe not a flaw, but just a kind of design or feature of OAuth, or it can be kind of tricky. So when we have that home run discovery page, right, we're making a condition on who is the user that we want to sign in, right, that email address. But when I get redirected to Google, I can't really force that user to sign in with that account, right? So I provided m.diante@gmail.com. So my system, I said, okay, great, I know him. So I'm going to go back to Google. Now, although I could provide that login, I can easily just take it off the URL and then sign in. So what's the mechanism we do to protect that? So I'm going to sign in with my other account, which I actually use Google Apps for my personal email. So I'm going to sign in. I got another one password. I'll sign in forever. Hopefully that's it. No, it's not. Here we go. Send me my request. Yes. Sign me in. Now Google's going to do its thing. And I got a weird error, right? The IDP returned m@monteledwards.com, which is different from m.deonte@gmail.com that was provided at sign-in. Please sign in with m@monteledwards.com account. That is a completely custom REST API that we just called. So, it's a feature of OAuth that I technically could do that, but my app wants to only allow the views that come in. So, right, we going back, right, we did, instead of doing claims enrichment, we should only going to do claims enrichment when the user is okay. We're going to do 3.1, which is verify IDP equals home realm. So very simply behind the scenes, that hit a REST API that said, if email equals home realm value, send a 200 response. If not, send a 403, and that's actually the error message that's responded back from the API. So you get a lot of flexibility there, right? I could say literally the email address that it was sent in, or I can say error, sign back in. A lot of options there.
Can't you just pass in that login hint and force them to sign in with
No, so it's not a force. That's the unfortunate thing is I technically, going back to like my Azure AD one, I could just take that off my URL, hit enter, and the URL is still valid. That hint isn't a security mechanism. It's just a recommendation for the IAP. The user could easily just take that off. And that's not like something, an element, a part of the token that changes its signature or anything like that to block the login. Some migration options. And this is honestly where we make a lot of our money with B2C. So you'll see how it gets interesting here. So we're going to talk about the not so fun ways and the intrusive ways, and we're going to talk about the fun ways to migrate users. So this is the way that I've never seen, but it's theoretically possible where, okay, I had an app that I was built in the 1950s, and I have a table and actually have the plain text value of my users' passwords. So this is pretty simple. I cut over my app. I just upload the passwords to B2C and we're done, right? But that's the requirement of I have plain text values for my password. Very, very unlikely if you're going to take on a new IDP that you've been working with at any, you started just capturing the plain text passwords of your user. So next thing, which I'm sure you've probably seen before, I've seen emails where they've been upfront with it. Hey, we changed a different IDP, you got to reset your password, right? We're in this flow. In the legacy IDP, we got to prevent signing up and prevent resetting your password. We migrate our users, and then we send a password reset link to all of our users. And they have to change their password before they sign in. Now, there's another option which is called just-in-time migration. So, sorry, there's a typo in that one I just did, where we do a just-in-time password set and then just-in-time migration of the user. So in this flow, what we do is we configure B2C. So right now we're talking username and passwords, right? So for whatever reason, my app doesn't want to bring your own identity. We actually want to work with the username and passwords. So in this instance, right, that instead of saying that email page, we sign email and password, where in our migration state, so where we have our new app that was just onboarded, and we still have our old IDP that's there. And our new app, we take that sign name and password, and then B2C behind the scenes sends that payload to a REST API. Now that REST API can either be an interface to my old app SQL server. So I'm going to send that payload into that REST API. It's going to do a rehash of that password, check if those values match. And then if they match, we're going to send in that request in. So I'm sorry, first thing we do is we check if the user exists in the directory. We've already migrated them or not. That's the boring part. But if they don't exist, then we're going to migrate them, check if that password is valid. If it is valid, migrate the account in and issue that token. So with that, right, we've seen SQL Server, easy one. Even easier is IDPs that actually expose a authentication endpoint. So if we're moving from like Okta or Ping1 to B2C, we have typically the ROPC flow where we can just send in that username and password and get a response back. But we have seen the worst, which is a client has a source system that has no API, no other mechanism of logging in other than logging into the web page, right? So we are in the process now of building essentially a farm of Selenium driving web browser agents to take that password real time, send you to the web page behind the scenes, which is whitelisted, so it's not going to think we're not servicing it, and sign you in, right? And that's an expensive effort, right? It's a lot of technology and there's a lot of infrastructure that goes around in maintaining that. But when we talk about identity, the impact it can have to your users to have them reset your password could be huge. I mean, you could lose your customer towards that, right? If you just have a SaaS application that people use, every so often. So, the just-in-time migration is huge, right? So that is how we win a lot of customers with B2C, as our flexibility to bring that account in and do whatever we want with it. So there's a lot of different other features too. We have auditing, very intense auditing. We can make correlations between, okay, did my user actually type in their password and sign in, right? How many users am I losing between that sign-in process, right? Is my IDP down? Making some analysis off of that. So that's about it for the B2C and the end of my talk. Any questions or anything?
Question on this one right
Yeah.
here. When I sign in on the very first step up here, I'm on a page. I'm on an Azure page. Right? I type in my username. I type in my password. At this point, I wasn't ported to Gmail. I wasn't ported to Ping One. I must be logging into some sort of Azure login page.
Yeah.
How do you tell Azure then to forward the username and password to my own REST API? Is that a B2C specific thing? That's not OAuth or IDC. That's got to be B2C.
Yeah, it's completely B2C. So, right, going back to that user journey there. So we get that input from the user, we get the username and password, and then within memory of our context of our session, we have access to that username and password. So we're taking your username and password value and sending that over in an encrypted channel to that API behind the scenes. So this is all happening in milliseconds to actually migrate that account over. So yeah, completely right from the user's perspective, they did the OAuth flow, but behind the scenes, we did that logic of migrating their account through. Yeah.
So with this, if you're dealing with customers that may not log in for 6 to 12 months and then come back, is the idea that you would support this or like the Selenium grid or whatever for like a period of time, after which they'd have to do a password reset if they're
100%. So when you're doing a migration, typically this doesn't cost much to run. I mean, in the Selenium one, that's ridiculous, right? But if I just have, if I'm moving off of like Okta or a decent IDP who has a queryable REST API, we pretty much align that with, okay, when's your license renew with them? Is it 10 years from now? Great, let's keep it open for the next 10 years. You already have it. But then yes, you're 100% correct. If it is maybe less than that, we define and we can perform analysis on it, a comparison. Maybe our target's 30% of the users or 50%. We at least want to get 50%. Once we get to 50% through just in time, then we'll accept, okay, these are the users that aren't hitting our service. Let's send them a password reset just so we can kill our old IDP system. Yep. Anything else? Awesome. Well, thank you. That's the end of our talk. I think we're pretty much just about on time.